Hello students, how are you all? I hope you all good. And today we are going to discuss this for NEET coaching. So in NEET Physics we are going to discuss. Today we are going to discuss NEET Physics in that Kinematics chapter. So before going to this kinematics chapter, as usual, let's close our eyes. We'll ask, God's presence. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Anyhow, now today, let's move on to the topic that is kinematics. All right. So in today's topic in kinematics chapter, that motion in one dimension. So in this motion in one dimension, we are going to discuss what is horizontal motion, and in this, which are the points you need to remember, because it is we are revising, means recapitulation for NEET physics exam. Because of that reason, we are going to learn which points we have to remember. So mainly in this horizontal motion or vertical motion, so you have to remember first point is what is rest and what is motion. So this we have to understand these two terms. So first, what is rest? See, an object is said to be at rest if the position of the object does not change with respect to the surroundings. For example, see, there is one bus. This thing as a bus. Okay, and this bus was stopped. Okay, so because of lockdown, bus was stopped at the depot, and now it is not at all moving. Whatever the surrounding will be, surrounding places the human beings may move, they cannot move, whatever it is. But according to this object is not moving and it was stopped at one place. That means that object is at rest. So that's the reason what I said, an object, whatever it is, whether it is bus or car or auto or human being, whatever it is, see, that object is said to be said to be at rest if the position of the object does not change with the surroundings. Okay, surroundings, then we can say that that object is at rest. And then motion means, already you know that this, if an object is moving, then that is called as object is in motion. But in definition form, if you want, an object is said to be in motion if its position changes with respect to its surroundings, with respect to its surroundings. So here it is not changing the position with respect to the surroundings. Here this object will change its position according to the or with respect to the surroundings. Okay, so surroundings will play here an important role. If with, according to the surroundings, if it is in the rest position, then object is in rest. According to the surroundings, if the object is in moving condition, then our object is in motion, then we can say that object in motion. So this is about what is rest, what is motion. So this is your first two important points. So if you want, I'll write one by one so that you can remember. Alright, this is your definition for what is a rest, what is motion. So an object is said to be at rest if the position of the object does not change with respect to its surroundings. And motion means an object is said to be in motion if its position changes with respect to its surroundings. These are the important points you just remember about rest and motion. And one more point you have to remember, this rest and motion are relative. rest and motion are relative. So what is meaning of that? How, sir, it is possible to be rest and motion are relative? For example, there is a bus. So anyhow, I love to share about the bus more. Okay. So think this is a bus or van, whatever it is, whatever you feel that you can think. Okay. Okay. So in this bus, there is a seat. So here one person sitting. Okay. So now I'm going to discuss according to his what is mean by rest, what is motion, how these both are relative. See, according to him, he is sitting in the bus. That means, so in bus, the whoever people are there, if they are sitting like this, according to that bus condition, inside of the bus people condition, so this person is in rest position. He is just sitting, so he is not moving anywhere, so that he is rest in the bus. But according to the outside people, this person is in motion, because this bus is moving and he is also according to the person who was the outside. So according to that, we can say that this person is in motion. So that's the reason we are saying rest and motion are relative. So that is about your first three important points which you have to remember. This is just we are revising the NEET Physics important points now. So after this, we are going to discuss some of the problems and you can understand how to solve this all. This is just an revision. This is very important topic in this kinematics, that is what is distance and displacement. So students, you have to remember what is the difference between distance and displacement. See, for example, this is a point A, so this is point B. Okay, so one person was traveled from here to here. This was the route. You are observed now here carefully. So from point A to B, whatever he covered by using vehicle or by using walk, however it is, he covered the distance between A to B. So we can say that the length between A to B is called as distance. So the length covered A to B is called as length, that is total length covered A to B is nothing but distance. Then the shortest distance between A to B, shortest distance between A to B is nothing but displacement. So you are understood now. So here to here, this shortest distance, whichever is there, that is called as displacement, and the total length covered by this person from A to B is called as a distance. So this is the difference between distance and displacement, and here it is distance is scalar quantity, only length will be, for displacement is a vector quantity. Okay, so next we are going to discuss what is the formula for displacement, what is formula for distance. Okay, alright, this is our next point, the difference between final and, means clearly I was giving what is displacement and what is distance. The difference between the final and initial position of a particle is known as a displacement. So displacement is a delta x that is equal to xf, means final velocity, this is final position minus initial position. Okay. That is about displacement. So now let's move on to the next point, that is displacement of a particle. Displacement of a particle. So displacement of a particle is the shortest distance between, I already said for you, is the shortest distance between between its initial and final position. Its initial and final position. Another point you have to remember it is final position, and you can remember next one is very important one, and directed from initial position to the final position means the direction will be, that's what I'm writing here, directed from initial okay directed from initial position to final position, because it is vector na, so when you are showing for example a b bar, okay, so that is nothing but directed from initial position to the final position. Okay, so next important point you have to remember, so the what is meant by distance. So till now we discussed what is a displacement. The difference between the final and initial positions of a particle is known as a displacement. So here you have to remember delta x is equal to xf minus xi. Okay, so that is about your displacement, and now let's move on to the distance. These are next two points you have to remember. The length of the actual path covered by a particle in a time interval is called distance. So means last time I was explained from point A to B. So it was covered like this, or maybe it is covered like this, or maybe covered like this, however it was done. This is called as actual path. So that is the length of actual path covered by a particle in a time interval is called as a distance. So here distance is a scalar quantity, means it's a number. Displacement is a vector quantity. Okay, so that is about your distance and displacement. Now let's move on to the another important point, what is speed. So in this speed we can learn what is speed definition, and then we can learn what is average speed and what is instantaneous speed. Okay, okay, now we are going to learn what is speed. For example, one object was moved from here to here, that means point A to B. So object is moved from A to B. So some distance is total covered. So that will be the D, and that distance is covered at some certain time. Okay, so then what is the speed of that object? So whatever the object, whether it is car or bus or the human being or whatever it is from one point to another point it was moved, and it covered some distance, and then that distance is covered with some certain time. So then speed one means that speed of object is equal to total distance covered upon total time taken. Okay, so this is called as your speed, and if you want to write like speed, s is equal to d upon t. So this is about your speed. So that means speed of a body is the rate at which it describes its path. Okay, and what is units, sir, for this? So SI units for this speed is meter second inverse, or we can say meter per second. So you can use any one, meter second inverse or meter per second also. So that is your SI units of speed. Okay. So now in this speed again different. Another important point in this speed is what is mean by uniform speed. This is again very important one. What is speed means this? What is uniform speed? So a body is said to move with uniform speed. A body is said to move with a uniform speed if it has equal distances in equal interval of time. So that means, so 5 seconds 5 meters covered, again the 5 seconds covered in 5 meters, in such a way it was there means. So has equal distances in equal intervals of time. However, the small the interval may be. That intervals means here to you have covered 5 meters covered in 5 seconds. And again from here to here it may be that is 10 meters in 10 seconds. Then 20 meters, that is in 20 seconds. Then 30 meters, that is in 30 seconds. So such kind way it was there means that maybe the interval may be the small also. Then we can say that it is in uniform speed. Okay. So here equal distances at equal intervals. Okay, that you have to remember. So equal distance need to be covered in equal intervals of time. Okay, that is about your uniform speed. Okay, so then a body is said to be, then if it is not in uniform, then what should be your, so unequal distances covered and unequal intervals will be, so then that is ununiform speed. Okay, so if I want to say write in a in a specific form method, I'll give for you that points, you just read that points. Okay, next we are going to discuss what is average speed. Before that, you remember these points. Okay. Okay, next you have to remember what is average speed, what is instantaneous speed. Instantaneous means at particular seconds. For example, so it covered from A to B. So it is 10 meters covered means. So at exactly 8th second, how much meters are covered? And total it was covered in 20 seconds peak. At 8th second, how many meters were covered? Means another one like 10th second, how many meters are covered? Means at that point, what was the speed? So that is called as instantaneous speed, and average speed you already know. So what is average speed? The formula is total distance upon total time. So it is very easy. Total distance upon total time. So that is nothing but your average speed. If in instantaneous change means that is d by dt of s. Here s means not speed. Here s means a distance. Okay. So here instantaneous speed is equal to ds by dt. So that is about your average speed and instantaneous speed. I hope you have understood what is average speed, what is instantaneous speed. Instantaneous speed means at that particular point or at that particular second how much distance was covered. So that we can say that instantaneous speed. Okay, so in that 8th second what is the speed, 10th second what is the speed. Okay, so that is about average speed and instantaneous speed. And now we are going to discuss some more important points. some two more important points which will help you to solve your problems easily. Okay. Important point. If a particle covers first half distance with a speed v1 and second half distance with a speed v2, then what is your average speed? Okay, so then they may say that find average speed. Okay, so now if a particle covers first half distance with a speed v1, second half distance with a speed v2, so that means what we need to do here it is, so here first let me say here that this was a point and this was b point and exactly half. Here to here it is v1 speed and here to here v2 speed. And what should be the average speed? Average speed is equal to 2v1 v2 upon v1 plus v2. This, remember, this is a very important formula. Okay. If it is divided into three parts, okay, so that means your 7th point, which was you need to remember, if a particle covers 1/3 of distance, that means first 1/3, okay, 1/3 of distance with the speed v1, with the speed v1. So I may write here easily, here it is point A and divided into three parts, and v1 speed, v2 speed, v3 speed. Okay, so first 1/3, 1/3, this is 1/3, 1/3, again 1/3. First 1/3 is v1, second 1/3 is v2, the third 1/3 is v3. So now what is what is your average speed? So average speed is equal to 3 v1 v2 v3 upon v1 plus v2 plus v3. This is your direct formulas. You just remember so that it is going to be very easy when you are solving your problems. So that is about your up to average speed, and next class we are going to discuss what is velocity and those. First let me solve here up to average speed whatever the problems are possible to solve. Okay, for example, I'll take here now the first for 6th.1 example, 7th.1 example, and I'll solve. See, they may give you in this, if a particle covers first half distance with a speed of 5 meter per second, okay, and another one it is 15 meter per second, what is your average speed? It's again very simple. 2 into what is your v1? v1 is 5, v2 is 15. 5 into 15 upon 5 plus 15. So you have understood, just v1 plus 5 substituted, v2 plus 15 substituted. So now 2 5s are 10, 10 into 15, 150 upon 15 plus 5, 20, 0, 0, and you get here 15 upon 2. 15 upon 2 is nothing but what you get, 7.5 meter per second. So that is your average speed. Same method now here also, like 1/3 of that is a speed they may given as like 5, and this may be the 10 and this may be 15 they given. Then how to solve? Again same method only, 3 into 5 into 10 into 15, because v1 is 5, v2 is 10, v3 is 15. So now 5 plus 10 plus 15. So when you multiply, what you are going to get here, 10 plus 5, 15, 15 plus 15, 30. So directly write here 30, and 3 into 10, 30 into 15 5s are 75. Now 30 cancel, we get 75 meter per second. So that is about your how to find average speed. Okay, so that is about your basics, 5 points, and once you try these all things, and after completion of this, I'll give for you some of the problems, and so that you can understand how to solve that need problems. Okay, may God bless you all.